Namaste and welcome back to our channel, Qubit Educational Services. In this video series, we are solving the physics MCQs from IISER Aptitude Test 2022, and this paper is available on their official website. In this video, we will be solving MCQ number 4, which is based on simple harmonic motion and elastic collisions. As shown in the figure, a block is resting on a frictionless floor and is attached to the free end of a spring. The right edge of the block is the right edge of the block in equilibrium is at a distance d from the wall. So this is our block, and its right edge, that means this edge, is at a distance d from the wall. Right? This is the wall. When the spring is compressed by a distance d by 2 and released, the time period of motion is t. Similarly, when compressed by a distance 2d and released, the time period is t0. Considering elastic collision between the block and the wall, what is the value of the quantity t0 by t? 2 by 3, 1, 3 by 4 and 1 upon 4. Now, to solve this problem, we have to first understand that in the first case, the spring is being compressed by a distance d by 2. Okay. So when the compression in the spring, the maximum compression, or let's call it amplitude, it is d by 2, the block executes SHM, right? The block will execute SHM completely. Why is that? Because if the spring is getting compressed by a distance d by 2, it will also get elongated by the same distance. Which means the right edge of the block, which we have highlighted previously in this red color, it will not collide with the wall, because the wall is at a distance d from the block, and the maximum that the block can reach, or the closest that the block can go to the wall, is d by 2. Correct? So the block executes SHM completely, and what is the time period? They are calling it t. Now we know that in usual notations, t is 2 pi by omega. Okay, and which is also equal to 2 pi root m by k. Now there is a specific reason why we have written this formula, although they have not said anything regarding the mass of the block and the spring constant of the spring. The conclusion that we would like to use from this formula is that t and omega are independent. T and omega are independent of the amplitude of SHM. Okay, t and omega are independent of the amplitude of SHM, which means no matter what the amplitude is, as long as the block's mass remains constant and the spring's constant doesn't change with time, it will always oscillate with the same frequency, even if the amplitude is different. Okay, yes. Now if we consider the next case where the amplitude is 2 times t, let's now consider this case. Now for this case, it is still SHM, but it is unable to complete it because the wall is coming in between the block and its destination towards right. But what does that mean? That means if we assume, if we start measuring the time from the center, we can say that x is equal to a sine omega t in usual notations, or in this case it will be 2d sine omega t. Correct? So this is the position that we are measuring of the block from the equilibrium position. Okay, so this is the equilibrium position. We may call this to be the x equal to 0 location. Now, how much time is our block going to take to go to left to the distance 2d, or x equal to negative 2d, and come back? To complete half the oscillation, it is still going to take half of this t. Correct? Because on the left side, there is nothing that is obstructing the block. So it can definitely travel a distance 2d to the left and happily come back to its mean position. So let's now consider the duration for this. Let's call it leftward movement. Okay, or let's say time taken to come back to mean position from left side, let's say from left side. Okay, so it means it is going leftwards, traveling a distance 2d and again coming back. This time has to be equal to t by 2. Why is it t by 2? Because if the wall were absent, the block would still have continued to the right, then again it would have come back to the center. So to and fro motion that would have continued. And the motion of SHM being symmetric about the mean position, if originally the time period is t and plus it is independent of the amplitude of SHM, no matter by how much amount you compress the spring, it will always take half a cycle or time equal to half the period to travel leftwards and come back to its mean position. Now the question is, how long does the block take to reach the wall and again come back to its equilibrium position? That is going to complete one cycle. Okay, so let's now modify this and say time taken to come back to mean position from right side. Okay, from right side. Now please note, in the example they have said that the collision between the block and the wall is elastic. Okay, the collision between the wall and the block is elastic, which means whatever velocity the block had or whatever speed the block had before it, when it reached the wall, it will be reflected, it will be sent leftwards with the same velocity. So we can now say that the total time taken by the block from mean position to right to the wall and again come back from wall to its mean position will be same. Okay, because of the elastic collision. So let me just sketch it here. It can only travel a distance d and it needs to come back. Okay, whereas in this case it was traveling a distance 2d to the left and it was coming back. Okay, now to calculate this time, let us again use the same equation, x equal to 2d sine omega t, because the equation is still the same. But now what we are interested in determining is the time taken for this block to travel from the equilibrium position to the wall. Okay, so when the block reaches the wall, what is the value of x? When the block reaches the wall, the value of x is d, isn't it? So let us substitute x as d, 2d sine omega t. Dd goes, sine omega t is half, omega t is pi by 6, so t is pi by 6 omega. But this time, the time taken to come back to mean position from right side, this must be 2 times pi by 6 omega, because pi by 6 omega is the time to reach the wall from the mean position. So pi by 6 omega, again pi by 6 omega, so 2 pi by 6 omega. How much is that? 2 pi by 6 omega will be pi by 3 omega. Alright, so what is t naught then? T naught is the time period in its new motion, so it will be t by 2 for the left part and pi by 3 omega for the right part. Okay, so we are almost there now. We have to now use the relation t equals 2 pi by omega, right? So we here can see pi by omega expression, so pi by omega will be t by 2, right? You need to put it here, where this pi by omega is present here, so you need to put it there, okay, as t by 2. So t naught is equal to t by 2 plus 1 over 3 into t by 2. Therefore, t naught by t, that's the ratio that we want, that will be half plus 1 by 6. So that will be 6 plus 2 by 12, 8 by 12, or 4 into 2, 8, 4 into 3, 12. 2 by 3 will be the ratio. 2 by 3 will be the ratio, and that is option A. That is option A. That completes the fourth question. Again, as I have told you many times, they tend to mix concepts and form a question. So to solve this question, it is not sufficient to know just the theory of elastic collisions or just the theory of SHM. You need to know both very well, only then you can apply and solve the question. And you can see many such instances, especially in physics. There was a problem in one of our PYQs where you had capacitor plates which were expanding due to the increase in the temperature, and we had to relate the capacitance with the expansion, and the thermal expansion coefficient was given. Okay, so you need to learn how to bring concepts from two related or unrelated topics and apply them as per the requirement. Okay, so I hope you understood the solution. In our next video, we will be solving question number